to the second lesson of Chapter 1. This time, we are going to explore another aspect of limit, one-sided limit. You encounter the definition of limit as a whole. Now, why do we say as a whole? Because apparently, our limit of a function can be split into two different parts, two different components that are left and right. Last time, we defined the limit of a function as the y value when your x value approaches a certain a value on the graph. However, what direction does our x value approach from? Look at this graph of y equals x cubed minus 6x squared plus 11x minus 6 as an example. I want to find the limit of the function when x approaches 2. To get to 2, we always have two different directions, from right to the left, which is when x goes from values that are greater than 2 to 2, and left to right, which is when x goes from values that are smaller than 2 to 2. Those are our one-sided limits, the limits of a graph at a when your x value approaches a from either left side, which we call the left-handed limit, or right side, which we call the right-handed limit. The combination of those two one-sided limits is our ordinary limit, two-sided limit. Here are our notations of our one-sided limits. The sign on the left of A indicates which direction our x value approaches from. Right is plus and left is minus. If a function has the same right-handed limit and left-handed limit at point A, which is L, then the ordinary limit, aka two-sided limit of the functions at A does exist and equals to L. Let's look at this example of the graph of y equals x cubed minus 6x squared plus 11x minus 6. The right-handed limit will be in purple and the left-handed limit will be in green. As you can see from the graph and its value table, the right-handed limit of the function has the same value as the left-handed limit, which is 0. Then, we can conclude that the limit of the function when x approaches 2 is 0. But can right-handed and left-handed limits are not equal to each other? Certainly. You are going to encounter those situations quite a lot. Has different values of right-handed limit and left-handed limit at point A, then the limit, aka two-sided limit, of the function does not exist at A. Types of functions you might find different values of one-sided limits at a point is piecewise. Quick recap. Piecewise function is a type of function that is defined by different expressions for different intervals of x values. Let's look at this example of the graph of this piecewise function y equals x plus 1 when x is smaller or equals 1, and y equals x squared plus 3 when x is greater than 1. The right-hand limit will be in purple and the left-hand limit will be in green. As you can see from the graph and its value table, the right-hand limit of the function is 4, which has completely different values from the left-hand limit, which is 2. Then, we can conclude that the limit of this function when x approaches 1 is undefined. I have a few graphs here of piecewise functions for examples. Can you spend some time to find the limits, right and left-handed limits, just by looking at the graphs? As x approaches 1 from the right side, our graph approaches 3. However, from the left side, the graph approaches 2. Since those two values are not the same, the two-sided limit does not exist at x equals 1. When x gets closer to 0 from the right, y gets closer to 0. In contrast, from the left, y gets closer to 2. Again, the limit does not exist at x equals 0. From the right of x equals 0, y approaches 2. The same value for the left-handed limit. So the limit does exist and equals to 2 at x equals 0. In terms of one-sided limit calculation, it is identical to how we usually solve limits. We still have two traditional ways of solving, using a value table or solving it algebraically. Let's do this example using two different methods I just mentioned. I have y equals x squared plus 5x minus 9 when x is smaller than 3, and y equals x plus 3 when x is greater or equals to 3. We need to solve for both right-handed limit and left-handed limit at 3 and determine if the limit exists at that point. The most important thing when solving for one-sided limits when dealing with piecewise is to determine which formula is needed to find which one-sided limit. This is pretty easy. Let's first find the left-handed limit at 3. Because a left-handed limit is finding the limit when x is approaching 3 from values that are smaller than 3, we have to use the first formula, y equals x squared plus 5x minus 9 when x is smaller than 3, because that is the interval where x is smaller than 3. In contrast, you have to use y equals x plus 3 when x is equals or greater than 3 to find the right-handed limit, because that is the interval where x is greater than 3. Method 1, value table. Simply approach 3 using the first formula to find the left-handed limit and the second formula to find the right-handed limit. As you can see from this table, x is approaching 3 from the left side and y is approaching 15. As x is approaching 3 from the right side, y is approaching 6. As those two values are different, the limit does not exist at 3. Method 2, algebraically. Do you remember how to find a limit algebraically? We just need to substitute 3 into the function. But of course, when dealing with piecewise, we need to know which function to substitute in to find which one-sided limit, but we figured that out already. It then becomes very simple. We get the same results using the value table method, with the left-handed limit equals 15 and the right-handed limit equals 6. Hence, the limit does not exist at 3.